really doesn't matter, just so you know. When we say arc sine, these two are the same thing. All right, with that taken care of, we also need to briefly recap our definitions. Once again, arc sine um, has a domain of -1 to 1 and a range of -pi halves to pi halves inclusive. Arc cosine has a domain of -1 to 1 as well, and its range is 0 to pi inclusive. And arc tangent has a domain of all real numbers, and its range is -pi halves to pi halves not inclusive. Um, we also have our cast. So cosine is on the top, all functions are here, and sine and tangent are here. Now, let's talk about some inverse properties of trigonometric functions that are going to be useful when we do this. Basically, this is just saying that our arc functions are true inverse operations, much like 2 times x divided by 2 is just x. Multiplication and division are opposite functions. So sine and arc sine are opposite functions. And once again, we have to keep in mind our domain and range restrictions when we're doing this. We have to always keep that in mind. However, sine of arc sine of x is just x, and arc sine of sine y is just y. So they're opposite operations. Same thing with cosine. Cosine and arc cosine of x is x, and arc cosine of cosine y is just y. Once again, keeping in mind our domain for the arc cosine function has to be from -1 to 1, and our output must be from 0 to pi. And tangent and arctangent, our domain is all real numbers, so it doesn't matter what's here or what this turns out to be, but our range restriction is -pi halves to pi halves inclusive, and tangent of arctangent of x is x, and arctangent of tangent of y is y. Now, one example of why this matters is if they're opposite operations, then you'd think that arc sine of 3 pi halves is 3 pi halves, because arc sine and sine cancel out, so we're just left with 3 pi halves left. However, sine of 3 pi halves gives us negative. Let's go to our unit circle. Sine of 3 pi halves is right here. That is -1. However, arc sine of -1, we have to write it as -pi halves because that's the only way we're in within this restriction that we have. Because our output of arc sine of -1 cannot be 3 pi halves because that's outside of this restriction. And I think I made a mistake in the last video when I had 2 answers. It should have just been the negative answer because that's the only one that's within the window. So let's do some examples. So, first off, we're going to do some nice easy ones. Tangent of arctangent of -5, well, is -5 in the domain of arctangent. Our domain for tangent is all real numbers. So this is within domain. So tangent of arctangent of -5 is simply -5. That's a true opposite operations problem where everything turns out nicely. Now, arc sine of 5 pi thirds. Well, what is sine of 5 pi thirds? We can do that. Sine of 5 pi thirds, that's on our unit circle, so let's come here. 5 pi thirds, sine of 5 pi thirds is negative square root of 3 over 2. So negative square root of 3 over 2 is at 5 pi thirds. That's cool. However, 5 pi thirds is not an acceptable answer. Remember, this is sine, so arc sine. We have to have an answer between -pi halves and pi halves. So instead of 5 pi thirds, what is an angle that is the exact same as that, but it's within that window. Well, this is our coterminal. So one way you could think of this is 5 pi thirds minus 2 pi. Remember, coterminal, we just add or subtract 2 pi until we're within the window. Well, what is that? That is negative pi thirds. Is negative pi thirds within our window of negative pi halves to pi halves? It is indeed. So this is the correct answer. So this is very similar to this statement up here. All right, so let's do cosine of arc cosine of negative 1 of pi. Well, the arc cosine of pi, for pi cosine, arc cosine, our domain has to be from negative 1 to 1. Is pi between negative 1 and 1? Pi is approximately 3.14. So this is not possible. It is outside of our domain restriction. Alrighty. Now, we're moving on to some that are slightly more challenging. You'll notice that these are opposite operations. Now these that we're going to move into are not, but we can still do them, and I'll show you how. So tangent of arc cosine of 2/3. First of all, is 2/3 within our domain of arc cosine. Arc cosine says our domain is negative 1 to 1, so 2/3 is just fine. However, 2/3 is not on our unit circle. So the way we're going to do this is we're going to draw a triangle. So arc cosine of 2/3. Let's come over here, and I will draw a nice right triangle. And 2/3, 2 and 3 are both positive, and it's cosine, so this is in the first quadrant. And 2/3 means the 2, so I'll just write this out. Arc cosine of 2/3. Well, cosine, this is adjacent over hypotenuse. So our adjacent side to our angle is 2, and our hypotenuse is 3. So we sort of need to find out what this is. Well, we can do Pythagorean theorem. We have the hypotenuse, and we have a side. So we're going to be taking the square root of 3 squared minus 2 squared, because we're solving for another side. So this is the square root of 5 over here. So this side is square root of 5. So we were looking for tangent of that. So what is tangent? Tangent is opposite over adjacent. So that is square root of 5 over 2. Now we're going to do cosine of arc sine of negative 3/5. Once again, negative 3/5 is not a unit circle, so once again, we will be drawing a right triangle. Is negative 3/5 within our domain restriction? Our domain restriction for arc sine is negative 1 to 1, so yes, this still works. So we will be drawing another right triangle. So let's go do that. So here we are. We're doing the arc sine of negative 3/5. Now negative 3/5, that means we've got a negative angle for sine, and sine is only negative in the third and fourth quadrants. But if you remember our CAS thing, cosine, all, sine, and tangent, that means what we're looking at is a triangle in this quadrant. So I'll just draw a triangle like that, and it's somewhere over here. Sine is opposite over hypotenuse. Opposite over hypotenuse, so that means this is negative 3, and this is 5. So what we're looking for is this side. And once again, we're looking for a side. We have a hypotenuse, so we're going to take this use Pythagorean theorem, and we have 5 squared minus parentheses negative 3 squared, and that equals 4. So that's a nice number. So what we were looking for, if you remember, was cosine. So cosine is adjacent over hypotenuse. So we're doing 4/5. 4/5 will be our answer. So these two that we just did, you have to draw a reference triangle, do a little bit of Pythagorean theorem to solve the rest of the triangle, but then they're relatively straightforward from there. And these answers do work. They're within the domain and range restrictions. Now these ones are similar, however they have variables in them as well. So we have the sine of arc cosine of 3x, where x has to be between 0 and 1/3. And this restriction is just to make sure that for all x's we choose, this is still within our domain of 0 to 1. And once again, because we're doing sine and some non-arc sine function, we once again have to go to our unit reference triangle, and we're going to draw this. I'll point out 3x is going to be a positive value, which means we're going to have a triangle in the first quadrant. Because it's positive, we'll just draw a triangle like that. Now, this is arc cosine of 3x. So this is 3x over 1, remember. So that means our hypotenuse is 1 because it's adjacent over our hypotenuse. And this side is 3x. Now, this is a little bit harder, but once again, it's within our capabilities. Our hypotenuse is 1, so that's 1 squared, minus side squared, so that's 9x squared. And that's what this side is. We cannot simplify that at this time. We don't know what x is, so this algebraic expression is the equivalent of this side. And we were looking for sine, so sine is opposite over hypotenuse. So the sine of this, sine of cosine, arc cosine to negative 1 of 3x equals opposite over adjacent, opposite over hypotenuse. Hypotenuse is 1, so we can ignore it. So it's just 1 minus 9x squared. All right, so this last one is the most challenging example, but that's okay. We have cotangent of arc cosine of 2x over 3. And once again, we have our domain restriction, our x restriction, so that this will still be from 0 to 1, which is what our arc cosine function domain must be. So once again, we're going to go over and use our reference triangle to work this out. So we have arc cosine of 2x over 3. Once again, this is positive, so this is in our first quadrant. We're just going to draw our arbitrary right triangle. It doesn't matter what it looks like. We just need a right triangle in the first quadrant. And we have our 2x is our adjacent, and 3 is our hypotenuse. So we have these. And this side will be our hypotenuse squared minus our adjacent squared. So that is what that is. 9 minus 4x squared is what the